Hello, everyone. Welcome back to another OpenSSF live stream. This is Ram. I'll be your host today, and we have a very exciting guest. But before we get into that, the present bunch of live streams that are going to do are leading up to the first ever SOSS Community Day in India. So, the OpenSSF is going to host a one-day event co-located with KubeCon India, and it's going to happen on the 10th December in Delhi. So this is a one-track, one-day event where we're going to chat about security things, and a lot of security experts from India have signed up to be a part of the SOSS Community Day, and it's going to be, in my opinion, a celebration of a lot of open source security stuff. I will share some links that you can use to find your way and register for SOS Community Day. Although I think we might have very few slots left. It almost filled the moment we opened it up. So, but anyhow, I will share information about what's in the event, what you can expect, and things like that. But today is not about an event that's going to happen in 15 days or anything. Today is about software security, and to share their experience with us, I welcome Abhishek. Hello, Abhishek. Welcome to the stream today.
Hey Ram, happy to be here. Thank you so much for inviting me.
So, some people might know who you are. Some people might, benefit from an introduction. So, why don't you take a couple of minutes to first introduce yourself?
Yeah, sure, I'll do that. Hey everyone, my name is Abhisek Datta. I think many of you know me as the creator and maintainer of VET, which is a free and open source tool in software supply chain security space. Uh, uh, so before working on web, I was leading the platform engineering team in one of the B2B fintechs. I would not say startup, mid-market company. I kind of started my career as more of a security researcher. I don't know, I mean, people who interact with me these days know about it or not. But when I started, I think it was the early days of the cybersecurity industry. It was more of, finding vulnerabilities in network servers, analyzing them, writing exploits, and demonstrating, exploitability of vulnerabilities and those kind of things. And then mostly I worked with startups. So very quickly, along with security research, I also did a lot of development of security tools and security products. And eventually, I moved more into the software engineering side of things. Currently, I run my own company called SafeTech. It is in open source software supply chain space.
So, in some sense, is it safe to assume that you sort of invented or predicted the future in terms of, software supply chain security could soon be a big thing, and it's now a big thing, and now you have your own company, and you have, all the means to tackle this massive global problem right now.
I don't think I will claim that I invented this because, like any other open source software, when I started, thinking about VET or writing VET, I was trying to solve my own problem. So, in my previous company, we were responsible for the security of the platform, and we did a bunch of usual things to get started with the application security program, like having SCA, SAST, DAST, and penetration testing and all these things in place. One of the things that we really struggled was these vulnerabilities in third-party libraries, and then there was also this SolarWinds related incident. We also were reading about various attacks that were happening in software which were consumed from third parties. So we were really worried that what can we do about it. Now, one of the problems that we were thinking that time, which kind of led to VET, was most of the SEA tools, or back then I would say that all the SEA tools would really scan a source code to identify third-party libraries or a container image to identify what all components are there, and then correlate with some vulnerability database and just throw a huge number of vulnerabilities. Now fixing them was obviously very difficult and it's still a problem, but one of the concerns we have is when we looked into our entire dependency tree, we saw that it's not just the popular libraries or the libraries which we as developers, depending on. They in turn bring a lot of other libraries, right? The transitive dependencies, and many of those are from projects which are not maintained, which have single developers or not very actively developed, or in general of questionable trust. So we wanted to figure out that, I mean, how can we really establish the process of vetting? So I think large organizations already had this process that whenever you want to add a new library or do something about third-party dependencies, you would have to go through a process of vetting. And generally, the vetting involves looking for known vulnerabilities, looking at licenses, looking at the maturity or the security posture of the open source project which published that library. Now, being a small team, we did not wanted to put all those manual processes in place. We wanted to automate that, and I think that is when I also found this. I think Google's initiative devs.dev, as well as I think that was the initial days of OSV, open source vulnerability schema, and I think even OpenSSL scorecard was also publishing data with an API and all these things. So I felt that a lot of public data is available, using which we can probably automate the process of vetting these third-party libraries, and that's when VET was born. So I kind of created VET with the goal of going beyond only known vulnerabilities and looking at other data sources like the popularity of the particular project, OpenSSF, whatever data OpenSSF scorecard was collecting, and based on that, you can probably automate the process of vetting. Now, one interesting thing, or one design decision that we took when we started VET was we figured that there is no common way of vetting packages, or there is no common opinion. Like some people would only consider critical vulnerabilities, some would consider critical and high vulnerabilities as not acceptable. Then I mean, for us, we wanted to look at popularity or the security posture of the open source project which is publishing a particular library in addition to vulnerabilities, right? So we felt that maybe adopting policy as code on top of all these publicly available data sources is the way forward. It would allow us to build a developer tool which is highly flexible and highly customizable, with the goal of automating the process of this package vetting. So that's how VET was born. I think the first version of VET was just an aggregator of publicly available data with this CEL, Common Expressions Language, as the policy engine. Now, one of the things I am, I don't know, I would say seeing the future or not. I had to choose between Open Policy Agent and Common Expressions Language, and I ended up choosing CEL because of a whole bunch of reasons. Primarily because it's very simple and it is very hard to write very complex policies in CEL, right? So one of the reasons we went ahead choosing Common Expressions Language. And then over time, I saw that even Kubernetes chose CEL as, I think, their policy language. So yeah, I think that was good. So yeah, that's how VET was born, as a policy engine on top of data relevant for package vetting. Yeah.
Nice. I mean, security is hard, open source complicates it. But I've observed that, the attitude of developers at large is, it doesn't matter how complex it is, because we don't care anyway. So um, it's it's a very difficult problem still, isn't it, managing teams of developers and having them focus on security and educating them about policy and pushing them in the right direction about creating and maintaining software. Even before, I mean, your experiences with building a tool and things like that, I want to talk about it. But even before that, give us a glimpse into Abhishek as an engineering manager, maybe, or a team, managing a team,
Yeah,
maybe a few
yeah.
years ago.
So I think I had a very interesting moment as an engineering manager for a while, for a couple of months, where I was responsible for some part of the platform engineering team as well as the security engineering bit of it, right? So I kind of experienced conflicting requirements. On one side, on the engineering side of things, I think the velocity or shipping features was the most important. Security was, yeah, required. You should not get compromised, but I don't think anyone would put security as part of my OKR as part of being an engineering manager. But on the other hand, I think on the security side of things, I also had to ensure that our security posture improved. So at some point in time, it was like I was struggling because one team was asking me that these critical vulnerabilities needs to be resolved, and the team which was responsible for resolving those was another team which was kind of reporting to me. And I knew that team's priority was totally different, and we had like very important customer commits. Or in general, what happens with platform engineering is that some of the platform initiatives are like foundational things, right? Other feature teams depend on such initiatives, so if we don't deliver, a lot of other features get impacted. So it was kind of hard balancing on both the feature delivery, the engineering bit, and the security side of things. Now, what I felt was from a software engineer's perspective, right? Uh, it is very hard to think about too many things, right? There is a way to professionally build software. Like when you are shipping a feature as a professional software engineer, you have to look into the requirements. You have to, especially if you're working on large code bases, it's not just writing those features, writing code to implement those features. You have to also look at a lot of other existing aspects of large applications, right? Whether it breaks something, you may have to refactor some bit of it. So there are just too many things to worry about. You have to write good quality test cases. You have to ensure that your feature or whatever refactoring or changes that you do does not end up breaking, the test suites and all of that. A lot of things to worry about. On top of that, if you also add security, it just becomes too much for developers. So, but it's as an engineering manager or as an engineering leader, it's very very important to ship secure product. So what I felt was the best of the security that works from say a platform perspective is really invisible security, which means security built as part of the platform. Maybe think of it as something guardrails built in the application framework itself, or appropriate tooling implemented in the CI/CD pipeline in all the entire DevSecOps bits of it, where it does not get in the way of developers who are primarily concerned about shipping features, but at the same time prevents developers from making mistakes which have a very high cost of security impact. So on the engineering side, I think if you look at security from the object, looking at from the security team side, if you want to ensure that the engineering team that you're serving ships secure product, I feel that security has to be as invisible as possible.
I think that's a That's a very good sentiment. Security should be invisible, but it should kind of exist and be ubiquitous and
It
have
should be guardrail should be there. Like say for example in SafeDev also, one of my concerns is that during the early days, how do we ship secure product? Even though as a startup we probably do not have a lot of assets to protect, but from my past experience, I have seen that if I don't care about security today, as we grow, it becomes a major security debt, and it's not easy to just fix things one sudden, one fine day. It's just not possible. So I am a big supporter of having the security team or the security engineering team building the necessary guardrails to prevent common security issues or eliminate vulnerability classes while being kind of invisible. I mean, particularly I'd like to call out things like, do not enforce manual security review before every single, feature release or things like that.
right. So, in terms of the parts that developers get versus the parts that they don't, I'd like to understand where security stands. Now, for example, I meet a lot of developers, they all understand that, hey, we need observability of some kind, and they'll go the extra mile to add telemetry to their applications, and they sort of know all of the tools in the space. Like they're aware of OTel and Open Telemetry in the CNCF space, for example, and they all know something about metrics and traces and stuff like that. And so they're willing to, like I said, go maybe not an extra mile but like an extra half a mile to add observability and things like that. But I don't often find the same kind of reception when it comes to security, and it kind of makes me a little sad at times. And but then that's also sort of my job now, to educate a lot of people about security and how to secure applications and things. And so what has been your experience, and how do people begin tackling such challenges in the workplace?
Yeah, so engineers care about observability because they have to be on call, right? Performance, availability, reliability of an application is owned by the engineering team. I mean, they are responsible for it. That's why they care by default. Say, for example, if you ship a feature and the production goes down, it's not someone else's responsibility. You, as the feature owner or the CRI, you will have to respond to it. You have to debug. You have to probably spend a lot of time looking into production and figuring out what went wrong. Immediately go for the necessary patches to fix the production, because it's the engineer's problem if there are production issues, which is why I feel both performance as well as observability bits are highly prioritized. But what I have seen in most organizations, there the security by default is not part of engineering. We extensively talk about shared security responsibility, but if you look at it, security comes under a different leader, not the VP of engineering or whoever is leading engineering, right? Yeah, we talk about collaboration, security champions program, having DevSecOps culture and all of that, but I am not sure if that sense of ownership really comes. Say, for example, uh, so many vulnerabilities. Like one of the biggest challenge with security is vulnerability management, right? It has been there. It has been there since probably 15 years back. It's still the same problem. Too many vulnerabilities. How to prioritize, what to fix, and how to ensure we don't get breached, right? Now, uh, the thing is that from a engineering perspective, mostly engineers see that there is a separate team who is responsible for finding security issues, creating tickets, and many a times there is a continuous conflict between security team and engineering team. Engineering teams many a times feels that many of the issues are irrelevant. These are theoretical issues, actually have no real life impact. Right. On the other hand, the security team feels that the engineering team does not prioritize security fixes. They don't care about security. core security culture and all of that. Now, there is, I think, there is definitely is a information silo or even a gap in the language which the security team or the engineering team speaks, in my opinion, or that's what I have seen, right? If in I think in organization where security is highly prioritized at the highest level, I would say maybe at the CEO level or the CTO level, there maybe the culture in both the engineering team and security team is such that they can probably truly invite this idea of security as a shared responsibility, where engineering team is also responsible for vulnerabilities in their production workloads. In that case, I think they will also start thinking of security at par with observability or other engineering requirements when it comes to not just building but operating software in production as well.
Yeah, I think that's an interesting cultural backdrop to um, what is essentially a technical problem, I guess. But I mean, hopefully the day comes when there's more maturity in dealing with a lot of the security issues. But um, I guess we'll have to wait until then. But let's talk a little bit about your current areas of focus, Abhishek. So you mentioned your building and maintaining an open source tool that has something to do with security and specifically software supply chain security and securing open source pipelines. Let's chat about that a little bit. You called it wet.
Yes, vet, I mean, comes from the original idea of automating the process of package vetting, which is, I think, a common process across various product security teams, right? Uh, Specifically, I think if I have to talk about software supply chain security, right, last year in 2023, when I thought that I'll build a company to solve the problem of software supply chain, I was too naive to even think that, I mean, a single company or a small team can solve the problem of software supply chain security. I'll explain why, right? So, if I think from the perspective of someone who is responsible for security, right, by default, I would consider my applications, my infrastructure, my not just cloud infrastructure, say on-prem infrastructure or IT infrastructure, as my assets, as things that I need to protect. Now, what has happened with, I think, ever since the SolarWinds hack and in general the rise of various software supply chain related incident, suddenly it seems like my scope has increased to not just the assets within my organization, but almost the entire internet. I mean, it's crazy big. Now, why the entire internet? Think about it, right? Every organization depends on open source. Like, yeah, you can't, no one, I don't think anyone can build a software today and not have exposure on open source. You can write every single bit of code in your application, but the compilers or interpreters that you are using comes from open sources mostly. The underlying platform, like if you're hosting on VM or even virtual machines or even a bare metal, those extensively use open source, right? So there is just too much dependency on outside my organization. And any security issue impacting these third-party dependencies. When I say dependencies, not just libraries, it can be anything, right? I'm talking in terms of component dependency, like I'm building an application, I'm dependent on some runtime components, which is running my application, or if I'm containerizing it, then everything is just part of the container, then underlying operating system and all of that. Now, those components which I'm directly depending on, they in turn depend on a lot of other components. It's like this massive supply of external software or external components getting into my organization. And I mean, how can I secure that? And if I don't secure that, or if I don't have a way to establish a guardrail that only trusted components can flow into my organization, right? Then there is just not, there is just not a reliable way of saying that my infrastructure or my product is secure. So, that's why I feel that the open source software supply chain security, or in general software supply chain security, is too big a problem. And when I look at it, I think to have reasonable security, we probably have to scope it down. For me, over the years, as I have learned more about software supply chain security, I have kind of scoped it down to application libraries. Yeah, so the same domain of SCA, software composition analysis, but I feel the problem is much bigger than conventional SCA. And I think even OpenSSF has multiple projects which is working on different aspects of software supply chain security, like probably working on the same fundamental idea that how can a software consumer establish trust on a software component which is coming from outside the trust boundary or outside their organization. So yeah, I think so that is the direction in which we are working. VET is also towards that direction, but scoped specifically to applications. And my company SafeDev is also kind of working towards that. Like, how can we make it very easy for software consumers to establish trust on open source packages before they decide to consume it, or take it as part of their application and then ship it to their customers.
So, in terms of who's a good user, or um, what's the sort of target persona for you,
Hmm.
what does that user look like? Are they already invested in security, or are they just investigating about security best practices? What kind of people are you looking for in terms of users for your
Yeah,
project?
yeah. So I thought about it last year. I think it doesn't matter what kind of persona I am looking for. It it probably matters like what kind of persona I discover as the intended users of the tool. Like initially, I thought that security engineers are the primary persona who will be using VET to really automate the process of vetting open source packages, because I mean that's what I have seen in many organizations, that when the engineering team creates a PR which introduces a new library, the security team is involved. They perform bunch of manual steps and we look at and then approve it, and then only the package gets in. In larger organization, you have this artifactories, like private repositories, where approved packages are stored. But over time, as I have interacted with different type of users, both on the engineering and security side of things, what I see currently is that most of the users of VET currently comes from security engineering teams, like people who are responsible for automating various security workflows, maybe DevSecOps teams and all of that. And also, I've seen platform engineering team, right? So some of the platform engineering teams who wants to ensure that any new packages or new application libraries that gets into their product is vetted, not just for vulnerabilities but also on the maintainability and maintenance and other posture side of things as well. Because one of the biggest problem with software composition analysis, SCA, or related to vulnerabilities in third party libraries is that it is easy to detect them. There is a problem of noise. Say, too many things are there. Suppose you figure out a way to prioritize also. Fixing is hard. You just don't have enough control to fix the vulnerabilities in third-party libraries that impacts your application. I mean, the obvious way is to update the library to a fixed version, and it's easier said than done because in very large application, especially the ones where the dependency tree is not really refreshed with a lot of legacy dependencies, it is incredibly hard to just update libraries, especially the framework libraries, and fix vulnerabilities. It just the newer version may not be compatible with the code base. It may impact other dependencies within the dependency tree. For example, I think I have faced the same issue because of a unmaintained dependency within my application's dependency tree. It was almost impossible to update core framework libraries, right? So, I mean, because of one of those libraries, the updates were very difficult because it was breaking the dependency constraints of one of the unmaintained libraries. So, what I am seeing is that apart from obviously the teams who wants to automate the process of software vetting, people are also careful not to introduce unmaintained libraries because one such library can make you stuck. It will even though that library may not have critical vulnerabilities, but that may cause you or prevent you from updating other libraries because of transitive dependencies or various dependency constraints. So yeah, I think both the security and engineering teams are currently the persona for vet.
Nice. Um, you know what? Enough chatting. Let's look at a terminal in in true technical webinars fashion.
Awesome.
You want to show us a demo of Vex and really show us what it's capable of.
Yeah, sure. I'll probably walk through the most common use cases and maybe also talk about the roadmap also. Let me know once my terminal is visible. Is my terminal visible? Ram, can you confirm? Okay.
Hey
Yeah.
Abhishek,
Please.
yeah, we can see your terminal. Go ahead.
Awesome. Okay.
Yeah.
So I think the first thing I will show is, say, for example, you have code base and you want to know about what are the vulnerable dependency. The most common SCA use case. I think every SCA tool does that. So Vet also does something like that. Say, for example, you can scan the entire directory, or you can scan a specific package manifest. Like in this case, we are scanning the gradle.log files, right? Which is a a log file for this Maven ecosystem for this package manager Gradle. So one of the things we try to do it slightly differently in Vet is that unlike most other SCA tools, which would probably give you a list of say 500 vulnerabilities, by default, when you say run Vet on a particular code base, what we try to do is internally use all the data sources that we have and kind of prioritize that what are the top 5 libraries that you should update to fix most of the issues, right? In this case, if you see here, it is just listing 5 libraries which has some critical and high risk vulnerabilities. If you also see, there is a impact score also. I know I've got this feedback multiple times that this impact score is a bit opaque, but the idea of impact score is that if you see here that even a high risk vulnerability is prioritized over a critical vulnerability because of this impact. So what we try to do is that since VET looks at data sources beyond just vulnerabilities, we internally treat multiple risk metrics. Unpopularity or OpenSSL scorecard based items are also considered as risk. So we try to, in this particular view, we try to tell the developers that if you manage to update only these 5 libraries, it should make a significant impact in your vulnerability dashboard. It should, fix a lot of vulnerabilities and also eliminate some of the other risks, right? So that's the goal. But WET can do much more than that. Say, for example, I was talking about this policy as code engine, right? So WET by default shows less information, but it also allows policy language, or it provides a policy language for slicing and dicing data. So before I do that, let me probably dump the data. This on. So what I'll do here, what I'm doing here is basically rerunning the same scan, but dumping the raw data into a particular directory so that I can use this policies, or in Let's language we call it filter, to find what we want, and not just Let's opinionated way of this risk, right? So let's look at how to do that. So we can do something like, say, wet query from, I think in this case, temp DCJ wet2. I think this is the one I used, right? So filter true. So by default, I'll just give a true filter which basically matches everything, which just lists every single component which was discovered by wet, and it also shows the GitHub repository when available. Now let's do some other queries as well. Let's look for components with which has at least a critical vulnerability, because that's one of the most common way for security teams to prioritize and find out that which libraries must be updated, right? Once critical dot exists, just a way of checking if there are any critical vulnerabilities. So you will see that wet will iterate over all the package metadata and apply the policy. This is basically common expressions language, CEL policies, and list only the packages which has at least a critical vulnerability. We can also do things like this, say once dot high dot exists true. In this case, it will list both critical or high risk vulnerability. Another common use case, I think, not too much in security, but more on the compliance side of things, is like looking for licenses. So let's look at that. Licenses dot exist, say L equal to say MIT. Yeah, so you can use filters to filter packages by their SPDX license code. And what else? Yeah, let's look at some of the other non-vulnerability related things. Let's try to find the packages which comes from a GitHub repository with, say, below certain stars. So let's see. So projects.exist p.type equal to GitHub, and then t dot say stars less than, let's say, 50. Yeah. So this way you can go beyond just vulnerabilities. You can actually find packages which comes from GitHub projects with below a star count. Just want to mention that personally, I don't believe star count as a strong metric for trustworthiness of a project. It can be abused. I mean, it is possible that you can use sock puppet accounts and all these things to pump up your stars and still push malware, right? But yeah, we do have this data so that if someone wants to use this as one of their filtering criteria, they can do it. And maybe Ram, you'll be interested that we also have the OpenSSF scorecard data in wet, so that we can filter for packages using the scorecard data. So we can do something like scorecard dot score c less than 5. So this is the aggregated OpenSSL scorecard score. You will see it lists all the packages which meets that particular filter using the OpenSSL scorecard data. We can also do specific checks we can also filter by specific checks. One of the most commonly used filter among web user base is this maintained data from OpenSSF support card. So let's see, maintained will say less than 5, right? So this way you can slice and dice your dependency tree and really look for what you are looking. You look for things that you want. Now, one interesting thing is that while the filters are really for you to find or navigate your dependency tree, you can put all those filters together and build a policy. That is what in web we called a filter suite or a policy. So it looks something like this. So it's a simple YAML file, which basically consists of multiple such filters, like whatever filters I showed, right? So let's see how we can use that as part of that. So let's run another scan. Say we can pass this filter suite, and we can also do something called filter fail. So this is something which is very useful in CI/CD integrations, where you can set up a policy-driven guardrail. You can define what is the filter criterias that is our definition of risk for you, right? So basically, you are codifying your opinion of open source risks into the policy.yaml file, and let's see. So if any of the filters in that policy.yaml matches, then that will fail with an error, which is basically useful in setting up guardrails as part of CI/CD. Almost done. Let's see. Couple of seconds more, and yes. So if you see here, these are the packages which matched the filters from policy.yml file. And if I don't know if it's visible at the bottom, sorry, but if you see here, it failed with a error code. If you look into the shell return value, you will see it failed with a non-zero error code, right? It helps break the CI/CD flow if configured properly. So this is one. And what else? Yeah. So one of the feedback that we have got multiple times from security as well as engineering team is that VET, like most other software composition analysis tools, throws or lists transitive dependencies as risky, right? So, but developers come back and tell me that I have not even added this particular library in my build.gradle file or say package.json, like where you define your direct dependencies, right? How come this library is there? And how do I fix it, right? So one of the features that we built was this. Let me run the scan and then maybe I'll keep talking about it. Let's scan reports. So one of the features that we built was how can we group, suggestions, upgrade suggestions related to transitive dependencies, like when a filter fails, or say when a risky component is identified, how can we group such risky components, which are transitive dependencies, with their direct dependency, because direct dependency is what you control, right? You can bump the version of direct dependencies, and which should in many cases also bump the transitive dependencies, thereby fixing some of those issues, right? It is not always the case, because dependency management is really complex. It's not just the transitive dependency versions because of one single direct dependency. There is a complex chain of dependency that may, there's multiple paths in the dependency graph to a particular low level or a transitive dependency. But many times what we have seen is that if you bump the version of direct dependencies, if those dependencies have vulnerable transitive dependencies, then they may add constraints that eliminate the vulnerable version of a transitive dependency, which would force the package manager to update them. This is just a convenience way like in this case, you see that all the vulnerable transitive dependencies are grouped by their direct dependencies. So you know that how a particular transitive dependency is introduced, right? When possible, you can bump up the direct dependency, hoping that it will fix it. But otherwise, you will probably have to add some constraints for updating the transitive dependencies also. Another interesting thing that we built in wet was dumping the dependency graph. So let me quickly figure that out. Yeah, report graph. Yes. So we have a bunch of features built, say DCJ graph, and I'll also add filter suite dot slash dot vet policy.ym. So the idea was sometimes you may want to visualize the dependency graph and see which are some of the risky components in your dependency graph as per your policy. Yeah, and then you want to see how those how does the dependency graph looks like. So that's why we built this report graph feature. So which basically dumped it into, say, look at this CGA graph, right? So it created the dependency graph as a dot file. Let's try to render this. Dot. This is DCJ graph. So let's put it as dot JPG. Yeah, but I'm not sure. I think because I'm sharing my terminal, I don't think if I open that particular JPG file, it will be visible. I will open it in a while, but let's first look at it, the dot file itself. Right. If you see the dot file, you will see that it's a typical, I think, graph-based dot file. Let me try to share the dependency graph, so how it looks like. Yeah, I hope the dependency graph is visible. So here I am rendering the dependency graph. If you see here, it kind of plotted the entire dependency graph consisting of direct dependencies and transitive dependencies. It also highlighted all those components, the packages for which one of the filter conditions matched from policy.yaml. So this kind of helps you to identify how deep is some of your risky dependencies, and how are they introduced, which all direct dependencies you have to update, or generally investigate how something got into your application, right? So this may be particularly useful, especially now when there are a lot of malicious packages. If somehow you figure out that one of your dependencies in your dependency graph is malicious, you can probably generate a visual representation of your dependency graph like this. And wet supports, I think, the malDT from OSV. So it can write policies to identify known malicious libraries, and then you can probably investigate it like that. So yeah, that's about it. I think that's a quick demo. One more thing that I want to quickly show is this. Let me just share my screen once more. So we use Wet for Wet's development also. So let me quickly pick up one of the close pull requests recently. Where is it? Please find something where we have done some dependency uploads. Yeah. So we do have a native GitHub action which wraps that and makes it very easy to integrate with GitHub Actions. So if you see here, this particular pull request was vetted by Vet. Like, we use this as part of a Vet's project also. So here a couple of policies failed. So it shows that popularity, maintenance, and security posture. If you scroll through it, you will see which all packages did not meet the criteria, and failed the vetting process. So at this point, it probably helps slightly on the pull request review. So you don't have to vet every single package which is introduced or changed in this pull request. You can quickly look at the ones which is flagged by vet. One of the interesting things that we are working on, it's probably going to take a while before that is released. We are also working on a way to do some deep package analysis or deep package inspection, so that we can make it easy even to make a decision on components with low probability. If you see here, this particular component is from a very well-known project, right? So component with popularity is low on GitHub start count. So these are just toil, like requires manual effort. So we are looking at how we can automate this also through code analysis and all these things, so that we can have reasonable trust, or we can do reasonable vetting of packages which fails the policy also, just to make it easy for the pull request reviewers to make a decision whether to go ahead or not. So yeah, that's about it. That's a quick demo of Vet. But Vet supports a lot of other use cases. So I highly recommend anyone who is looking to automate the process of vetting open source package for your applications to have a look. And we mostly build features in response to features requests from users. So please do submit feature request if something is missing.
I had a couple of questions, Abhishek. So, what's the starting point? The GitHub repo. Where do we get wet from?
Yes, let me share my screen again and do this. Uh, I think the best starting point is the GitHub repo itself. It's github.com/savedev/vet. It has, I would like to believe, decent documentation for anyone to get started with vet, both in their local system where they are running vet against a code base, doing everything that I just showed using filters and policies, and eventually setting up the GitHub action, right? So all of this information is there. We do have a documentation portal also. I think a lot more work is required in order to make it better. But I think in the documentation portal, we do have specific use cases. Say, for example, if you have a particular use case of, say, dependency inventory or some code analysis related things or GitHub code scanning integration. So use case specific documentation is there on our documentation site. But getting started with Vet as a tool, I think the best and most up-to-date documentation is the GitHub project itself.
Awesome. And then the other question I had was, you showed a Java based example with like Maven and other things. And then some of your other things inside GitHub, which you showed just now, had some Golang stuff. So I assume that this will all work irrespective of like the language you choose, or supports most
Uh,
popular languages that human beings use, or what's
no,
that like?
I can't say that it supports the most popular languages, because last when I read this Stack Overflow developer survey, I figured that there are a lot of popular languages.
Yes.
Yeah, but I think Vet has decent support for Java, NPM, and JavaScript, TypeScript ecosystem. Go, particularly because Go Vet is built in Go, as well as Python, PyPy ecosystem. Right, that's the I think the most supported one among I think Vet's user base. Mostly it's used using that. Vet also supports Ruby Gems ecosystem. One of the things I
Okay.
specifically like to call out, because I think one of the important data sources that Vet depends on is deps.dev, right? Which basically Google's project to aggregate a lot of open source intelligence, package intelligence data. So deps.dev don't support Ruby Gems, but what we do is that we import the database published by rubygems.org and make it available as an API, so that Vet can query equivalent package related data from the Ruby Gems ecosystem as well. So VET has support from Ruby Gems, and there are, I think, fair number of users who use VET for Gems, Ruby Gems as well, because a couple of other tools do not support Ruby Gems.
Got it. Got it. Yeah, I think it's a very interesting tool. Do you imagine a lot of people using this as part of their automated pipelines, or do you imagine that this is more for security researchers to make use of, or would it be a case of both?
As far as I know, see, VET is an open source project. We don't enforce any authentication or anything. So I don't know exactly who are using VET.
Sure.
I get to know only when people ping me on LinkedIn, or they create GitHub issues, or in general come to our Discord and say, this is not working. Can you add this feature? So that is when I get to know who is using VET. Most of the cases I see people start by uh, I mean, by people, I mean, most of the cases I see security engineers start by running that manually against a code base, then use the filters to navigate through the various risky components and all of that. But eventually, they add it in the CI/CD using GitHub Action. Whoever is using GitHub Action, since we have a native GitHub Action, it is very easy to get started. So they just put it in GitHub Action to automate the process of package vetting. So most of the organization, most of the users, I mean, they have an internal policy to vet open source packages. So they use the policy support of vet and GitHub Action to achieve that.
Nice. Cool. Yeah, those were all the questions I had. I really loved the demo. Definitely going to give Vet a spin after our chat today, and I encourage everybody viewing this to try Vet and give Abhishek and his team some feedback, and anything you can do to use up and coming open source projects and give some feedback, and you know contribute if you can a little bit, is mostly appreciated. um, but yeah, just a couple of quick announcements. There's a bunch of different free security courses whose QR is in a corner there somewhere. So if you're watching this, I encourage you to take advantage of that. But Abhishek, thank you so much for taking the time out of what I'm sure is a very busy schedule to come out in the open and share your security story with us.
Thank you so much. We are really happy to do it. Yeah, I think, OpenSSF is really an impactful project in my opinion, and it depends on many of the OpenSSF projects as well.
Yeah, I'm glad the project is inspiring people to build a lot of things over and above um, the basic toolkit that is a part of the OpenSSF. Um, but yeah, I think it was amazing about showcasing what can be done. And our next live stream, if you're watching, is tomorrow. So we have Barun Acharya from Acunox, who's doing a little bit of show and tell about building security tools and what challenges can come from that. So it's going to be at the same time, so 2 p.m. India time. So if you're around, do catch us there. But once again, thanks so much, Abhishek, and thanks so much to all our viewers today. I hope to catch you in a future stream. Bye bye.